Hi, welcome to my YouTube channel. This video I will introduce the concept of subset. So, as my previous video, I introduced that set like the box, and we can grab anything we want into our box. Like we can grab 1, 2, 3, 4 in our box or in our set. So, what is a subset? Which means we can collect our objects together into a small box or into a small set. Like we can collection 1 and 2 together, collection 1 and 3 together, 2 and 4 together, or we can only collection 4. So in mathematics, if we have a set S and set T, we said S is a subset of T. If and only if every element of S is also an element of T. I will introduce notations to express a set is a subset of another set in mathematics. The first guy is this one. This one means is a subset of. Conversely, if we want to express a set is not a subset of another set, we can use this one to indicate it isn't a subset of. Let's look at two possibilities here. First one, we can recall some information about equal set. Every element of S is also an element of T. It indicates S is a subset of T. And the second criteria of equal set is every element of T is also in our set S. It indicates T is a subset of S. So for example, if we have a set T here, which has elements 1, 2, 3, and 4. If we want our set S equals our set T, which means S must have elements 1, 2, 3, 4 as well. It indicates S and T share the same elements. It is equivalent to S is a subset of T, and T is also a subset of S, also equivalent to S equals T. The second possibility here is a proper subset. If we have two sets S and T, how do we know S is a proper subset of T? We still have two criteria should be satisfied. The first one is every element of S is also an element of T, which indicates S is a subset of T. But if you can find an element in set T isn't an element of S, then it indicates T is not a subset of S, which also equivalent to S and T are not equal set. Then we can say S is a proper subset of T. For example, here, if we have a set T has the elements 1, 2, 3, and 4, and S has the elements 1, 2, 3. In this case, 4 is an element of T, but 4 is not an element of S. It indicates T is not a subset of S. But 1, 2, 3 are element of S, and 1, 2, 3 are also an element of T. It indicates S is a subset of T. Then we can conclude that S is a proper subset of T. Let's look at the specific example. Given a set S has elements A, B, and C, how do we find the subset of this set? So we should to recall that the elements of a subset of S are only included A, B, or C. So let's consider there are only one element of our subset. Then it could be a set has element A, or a set has element B, or a set has element C. If there are two elements of our subset, then it could be a set has element AB, or a set has element AC, or a set has element BC. If there are three elements of our subsets, then it is S itself. Each set has element A, B, and C. Finally, a empty set is also a subset of S because empty set is a proper subset of all non-empty sets. And also, empty set is an improper subset of itself. How do we prove a set is a subset of another set? Let's look at a specific example here. We have two sets A and B, and the set A has the integer elements m, which are defined as 6 times or plus 12 for some integers r. And the set B has the integer elements n, which defined as n equals 3 times s for some integers s. How do we prove A is a subset of B in this case? So if we want to prove A is a subset of B, then we must show every element of A is also an element of B. So we can randomly choose an element X from our set A. Then we must show that X is also an element of B. By definition of the B, this means we must show that X equals 3 times some integers. Then, by definition of A, there is an integer r such that X equals 6 times r plus 12, given that does X times does 6 times r plus 12 equals 3 times some integers. Yes, because 6 times r plus 12 and it becomes 3 times 2r plus 4 and equals 3 times some integers. Then let s equal 2r plus 4. We must show that s is an integer. Is s is an integer? Yes, s is an integer because products and some integers is also an integers. Now we have to check x equals 3s because we let s equals 2r plus 4. Then x equals 3s equals 3 times 2r plus 4 equals 6r plus 12 equals x. Therefore, by definition of the B, x is an element of B. Then, which means A is a subset of B. How do we disprove that B is a subset of A? So disprove that B is a subset of A, which is equivalent to prove that B is not a subset of A. What's that mean? We must find an element of B that is not an element of A. Because if a set is a subset of another set, then every element of this set is also an element of another set. But if a set is not a subset of another set, then there exists one elements are not an element of another set. So by the definition of A and B, we must find an integer x of the four 3 times some integers that can't written in the form 6 times some integers plus 12. And now we can check some numbers, like we can check x equals 3. Then it also equals 3 times 1, and 1 is integer, so x equals 3 is an element of B. So if x equals 3 is an element of A, then we must have 6 times some integers r plus 12 is also equals 3 for some integers r. Then we can calculate the value of r first, and we can divide it by 3 first. It becomes 2r plus 4 equals 1, and 2r equals minus 3, then r equals minus 3 over 2. But minus 3 over 2 is not an integer. Then we can conclude that 3 is not an element of A. But 3 is an element of B. So B is not a subset of A, which is equivalent to disprove B is subset of A. Thanks for watching my YouTube videos, and you guys can leave your comments below and provide some suggestions for improving my YouTube video quality. And if you have any other questions, or if you have other topic you want to listen, you can also leave your comments. And in my next video, I will continue to talk about set theory, power sets in particular, and some basic Venn diagrams and set operations.